Okay, for this lesson, we are going to be looking at sets of data and determining if that data models a linear function, quadratic, or exponential. So the way we're going to do that is we are going to look at the differences between the x and y values. And we have some rules that tell us which type of function our data can model. So if we look at the bottom, if we have a constant first difference between y values for evenly spaced x values, then it's going to be linear, okay? This is first differences. For quadratic, we want constant second differences for evenly spaced x values. And then the last one, exponential, notice how it says ratios, constant ratios for evenly spaced x values. So for all three types of models, we want our x values to be evenly spaced. So that's the first thing we're going to check. If the x values are not evenly spaced, then we don't even have to worry about our problem. Once we've determined that our x values are evenly spaced out, then we're going to check the y values to see if they have a constant first difference, second difference, or if neither of those work, if they have a constant ratio. So let's go ahead and look at our first example. So we want to see, do our x values, are they evenly spaced out? So if I look from 12 to 16, that goes up by 4, up by 4, up by 4 the whole way through. So check, they are evenly spaced out. So it's either going to be linear, quadratic, or exponential. So let's go ahead and check and see if it's linear. So it says constant first differences between y values. So we need to take the y values and we need to subtract all of them. So if I subtract 3.6 minus 0.8, this gives me 3.52. I'm going to subtract again, 16.2 minus 3.6 gives me 12.6. Well, those right there are not the same. So we can already eliminate linear, but we're not sure if it's quadratic or exponential. So to determine the difference between those, we have to finish finding our first differences so that we can then find the second differences to determine if it is quadratic. So I'm just subtracting 328.05 minus 72.9. That gives me 255.15. So those are my first differences. Those are not the same, so we already can eliminate linear. Now I'm going to find my second differences. So I'm going to take these numbers here, and I'm repeating the process, subtracting 12.6 minus 3.52. That gives me 9.08. Okay, 56.7 minus 12.6. Well, that does not give me 9.08. Those are not the same. So it's not linear because the first differences aren't the same, and it's not quadratic because the second differences aren't the same. So that means the last thing we need to check is the ratio of the y values. Okay, so the ratio of the y values, this is a little bit different. Ratio means we're going to divide them. So I'm going to do 3.6 divided by divided by 0.8. And that gives me 4.5. All right, now let's do 16.2 divided by 3.6. Okay, my point's not working. Which gives me 4.5, and then 72.9 divided by 16.2, which gives me 4.5. So notice that my ratio, they all have the same ratio of 4.5. So since that's the case, we have evenly spaced x values for constant ratio. That means the answer to this one is going to be exponential. All right, that's my first one. My second problem, we're going to start the same way. Check and see if the y values are evenly spaced. Ooh, that's not a 3. Okay, so this goes up by 6, by 6, by 6. So yes, this one does have evenly spaced x values. So now we want to check our first differences between the y values. So I'm going to subtract 17 minus -1, that gives me 18. 17 to 35, that also gives me 18. And notice that each time when I subtract, I'm getting the number 18. So this has constant first differences, which means we're done. This is a linear function. All right, last one. Start the same way. Check the first differences. So this goes up by 5, 5, 5. Yes, it works out. So now we need to determine, is it linear, quadratic, or exponential? So let's go ahead and find the first differences. So negative 55 minus negative 100 gives me 45. And then 40 minus negative 55. Okay, so it's not linear, but we still need to finish it out. Because we need our first differences if we want to calculate the second differences, minus 185. Okay, so these are our first differences. They're all different, which is fine. And now if I calculate my second difference, if I do 95 minus 45, that gives me 50. 145 minus 95 gives me 50. And 195 minus 145 gives me 50. So these have constant second differences, which makes this function quadratic.